Right. So, what is the first MCQ from chemical calculations they have given? MCQ number 4. So, this is very interesting MCQ. Let's see. When the compound capital X having carbon, hydrogen, and oxygen only was treated with excess acetyl chloride, a compound having a relative molecular mass 126 units higher than that of X was obtained. The number of hydroxyl groups in X is, right? They have given when the compound capital X having carbon, hydrogen, oxygen only was treated with excess acetyl chloride, a compound having a relative molecular mass 126 units higher than that of X was obtained. The number of hydroxyl groups in capital X. Remember, students, in organic chemistry, there is a reaction like acetyl chloride. Now, this is acetyl chloride, CH3C double bond. Don't worry, you are learning these things in unit number 7, 8, right? 7, 8, 9, 10, organic chemistry. Okay. So 2025 LL students, they know that one. They have already learned these things. But for 2026 LL batch students, they still don't know. So this is actually known as acetyl chloride. Okay. See, double bond Cl group is there. Therefore, acetyl. And this can react with alcohols. For an example, just imagine ethanol. It is reacting with ethanol to produce this kind of an ester. So this is considered as ester, CH3, C double bond O, OCH2, CH3. Byproduct is H. Okay. So therefore, what will happen is the chlorine atom in that acetyl chloride is reacting with the hydrogen in this hydroxyl group. So this is known as hydroxyl group. Hydroxyl group. Hydroxyl. So hydrogen atom in the hydroxyl group is eliminating with the chlorine atom in the acetyl chloride and producing this kind of an acid. So remember this process, right? So this process is very important, will be very helpful for us to go for the answers. Right? Now, they have given that when the compound X, capital X having carbon, hydrogen, oxygen, only was treated with excess acetyl chloride, compound having a relative molecular mass 126 units higher than that of X was obtained. The number of hydroxyl groups in that capital X. Now here we have only one OH group, but in the compound that they have given, there are more than one OH group, hydroxyl groups. So we have to find how many hydroxyl groups are there. Now students, we can understand that according to this reaction, this acetyl chloride is reacting with the compound capital X, right? And producing another compound. So let's consider that one as Y. So they have given that the molar mass of that capital Y is greater than 126 units than capital X. They have clearly mentioned that. That means just imagine the molar mass of X is capital M, then the molar mass of capital Y is M plus 126, right? So the molar mass of capital Y is greater from 126 units than capital X. Then they're asking how many OH groups are there, right? How many OH groups are there? Now students, look at this one. Now you have to understand something like this. This chlorine atom is removed from the acetyl chloride. Then the remaining group is CH3, C double bond O, right? So therefore, I can say that the mass of newly added group. What is that newly added group to the compound? For capital X, what is the newly added group? The CH3C double bond group. So there you can see that 2 carbon atoms are there, 12 into 2, 1 oxygen 16, and 3 hydrogen. So therefore summation will be 24 plus 16 plus 3. So that is 43. 43 grams per mole, right? Per 1 mole. Huh? Then from capital X, a group is removed from that compound. What is it? Hydrogen. Hydrogen is removed. Ne? Hydrogen is removed. Then I can see that the mass reduced. The mass reduced from the compound, from capital X. What is it? If I consider one molecule, one hydrogen is removed from that one. So therefore, one hydrogen is 1 grams. That means, students, for capital X, you have to understand that 43 grams per mole, per 1 mole, 43 grams is added. And per 1 mole, 1 gram is removed. Hydrogen is removed. Hydrogen is removed with the chlorine. And the CH3C double bond is coming to the compound here in this way. Then tell me what is the net increment of the group, right? So I can tell that the net increase in the mass of capital X, right? 43 is added, 1 gram is removed. So therefore, net increase in the mass of capital X is 42 grams per mole. Can you understand? That means when you consider 1 acetyl chloride with 1 mole of this capital X, this CH3C double bond group is added to that compound and hydrogen is removed. So CH3C double bond group is 43 grams per 1 mole and hydrogen 1 gram per 1 mole. So therefore, what is the net increase in the mass of capital X per 1 mole? 42. Can you understand what I'm saying? Raise your hand, those who understood the explanation. Tell me if you have any doubts. Right? Do you have any doubts there? Yes. What are the doubts you have? So can I explain it again from mass of newly added? Yes. Now look at this one. Now listen to this one very carefully. Yeah? Me? So there is a capital X compound. Capital X compound is containing carbon, hydrogen, and oxygen. Finally, they have given in the question that how many hydroxyl groups are there in that compound. Students, this is actually very familiar reaction for us in organic chemistry, but don't worry, 26 students didn't learn this one yet, but you will learn sooner. But 25 students, you know that one, right? So now everyone can know this one because this reaction is very famous. This is acetyl chloride. That acetyl chloride is reacting with alcohol. So this is ethanol. In that reaction, what will happen is, in alcohol, we know that OH bond is breaking, hydrogen is removed because there is acidic nature, and chlorine is coming with this hydrogen, then HCl is produced as a byproduct, then the main product is CH3CW. Now you have to understand here the two processes will happen. You will see that the two changes you will see two changes in this alcohol molecule. What are the two changes? Hydrogen removed from that compound and newly CH3C double bond group is connected to that compound. So that alcohol group, according to the question that they have given, is capital X. But remember, there are more than one OH group. That's what they are asking. how many OH groups are there, how many hydroxyl groups are there in the compound. Correct? So therefore, there are more than one OH group. Then you can see that if the now for a saying I'm saying that just imagine there are 5 OH group, then what will happen? 5 hydrogens will be removed and 5 this group CH3C double bond of 5 groups are connecting to that. Can you understand? So here I got that for 1 mole I'm just considering the mass of newly added group. So therefore this is the newly added group, right? For 1 mole it is CH3C double bond means 2 carbons, 1 oxygen, 1 3 hydrogens. So therefore we can say that 43 grams more. So that is the newly added group for 1 mole. And hydrogen is removed from the compound. So therefore 1 gram is added newly. Hydrogen is 1. Then what is the net increase, right? You can see that 43 is added, 1 is removed. So therefore how much added as the total? 42. Right? In that process, 43 grams newly added to the compound, newly added to the capital X from this reaction per 1 mole of OH group. Per 1 mole of OH group. Students, they have given me after the reaction, the mass, the total increment of the compound is 126 units. 126 units, the total increment. X was capital M, Y, which is obtained from the product, which is obtained from the reaction between acetyl chloride and that compound. The increment of the mass, the total increment of the mass is 126 units. Units means grams per mole. Then you have obtained here for 1 OH group, right? So this is the net increase of the mass of X for 1 OH. You can say that for 1 OH group. 42. Then here the total increment is 126. Then tell me how many OH groups are there. If the increment is 42 for 1 OH group, then what is the number of OH groups for increment 126? You have to divide this 126 by 42. And what is the answer? 1, 3 here. That means in the compound, there are 3 OH groups. Can you understand? In this capital X compound, there are 3 OH groups, right? Because with 3 OH groups, we know that 3 chlorines are eliminating. So in order to have 3 chlorines, we should have 3 CH3C double bond groups. That's why increment is becoming 126, right? Okay. The reason I thought to choose this question to discuss with you under the chemical calculation. Actually, I can categorize this one under the organic chemistry also. But the calculation part is very interesting. That means we sometimes we don't think this kind of things in the exam, students. අර මේවා එක එකපාරට ඔලුවට එන්නේ නැහැ exam එක වෙලාවෙ. ඔයගොල්ලෝ මේවට පුරුදු වෙන්න ඕනේ. Understand? So these are some situations. These are some critical situations in calculations. You have to practice these things. Okay. So there are some good past paper questions. I'm not telling that all the past paper questions are easy. There are some good, a different level of thinking past paper questions are there. Right. So this is one of the very good, very interesting question that they have given from chemical calculations. Right. Okay. Raise your hand, those who understood that discussion. If you have any doubts, put your doubts in the chat box. Raise your hand, those who got the answer before I do this calculation. No one is there, right? It's okay. Maybe you don't know about the reaction yet. So answer is number 3. MCQ number 4, answer is 3 hydroxyl groups are there. Right, okay. Now, so let's move to the MCQ number 7. MCQ number 7. So let's see what kind of a question is that. MCQ number 7. A mixture of ferric oxide, Fe2O3, and ferrous oxide, FeO, is found to contain 72% of iron by mass. The mass of Fe2O3, ferric oxide, in 1 grams of this mixture. Right, okay. So there is a mixture that contains ferric oxide, Fe2O3, and ferrous oxide, FeO. They have given that iron percentage is 72. And if we consider 1 gram, they're asking what is the mass of Fe2O3. Fe2O3. So there are no inert substances, only these two. Right. So since they have given the total mass is 1 gram, let me find out here. Let me take that. Mass of Fe2O3 is x grams. Then mass of ferrous oxide is 1 minus x grams. 1 minus x. Right. Then what is the molar mass of Fe2O3? Iron is 56 into 2. Oxygen is 16 into 3 grams per mole. So therefore the molar mass is 112, here 48. So therefore 160 grams per mole is the molar mass of Fe2O3. And what is the molar mass of FeO? Ferrous oxide, 56 plus 16 grams per mole. So it is 72 grams per mole. So this is the molar mass of ferrous oxide. Right. Then students, what is the number of moles of Fe2O3? Mass divided by molar mass, x grams divided by 160 grams per mole. So it's giving that x over 160 moles. What is the number of moles of ferrous oxide? 1 minus x divided by 72. Right? Got it? Now, I can find out the total iron moles. Right? Total iron moles. I can say that total iron moles given by Fe2O3 and total iron moles given by ferrous oxide. We know that in ferric oxide, there are 2 iron atoms per 1 molecule. So therefore, number of iron moles given by ferric oxide is this amount into 2. Got it? This amount into 2. Plus, in this molecule, there is only 1 iron atom for 1 molecule. So therefore, same number of iron moles are given by this one. Here is the total iron moles in the compound. Then what is the total iron mass? Right? What is the total mass of iron? This expression, so this is x over 80 plus 1 minus 6, 72 moles multiplied by, what is the molar mass of iron? 56 grams per mole. Then per moles will cancel off. Then the mass is x over 80 plus 1 minus x over 72 into 56 grams is the total mass. Okay, it's the total mass. First of all, come up to here. Do the calculations correctly. Right, okay, now remember students, our target is to find out X value, right? So in the question they have given total iron percentage is 72. Then we can use that information. Iron percentage is 72. So what is the total mass of iron? X over 80 plus 1 minus x over 72 into 56 grams. So the total mass is 1 gram multiplied by 100%. And then this is equal to 72%. Percent value will cancel off. Grams will cancel off. I can shift this 100 for this direction. So therefore this becomes 0.7. And here we have x over 80 plus 1 minus x over 72 into 56. Right? So I think that these two values are divisible by 8. Ne? Yeah, 8 into 7. Here 8 into 0.09. Okay. Then here I can take a common denominator like 80 into 72. Here 72x plus 80 into 1 minus x. Zero 0.09. Then here we have 80 minus 8x. 72 minus 80. 0.09. Then we have an answer like, so this is divisible by 8. 8, 10 minus x, 10 into 72 into 7, 0.09. Okay. Then we have 70 minus 7x, 0.09 multiplied by 10 multiplied by 70. Therefore, we have 72 multiplied by 9. 64.8. Therefore, 7x equal to 70 minus 64.8. 5.2. Then x equal 5.2 divided by 7. What is the answer? 5.2 divided by 7. 30, 20. Right? So approximately 0.74 grams. Do we have that kind of an answer? 0.74. Question number 7. Answer is number 4. Yes, we got the answer. Answer is number 4. MCQ number 7. Answer is number 4. Right? Yeah, if you know the calculation tricks, actually you don't have to use logarithms. So I didn't use logarithms here. Okay. Little by little, step by step, you have to continue the question. You have to push the question for the final answer. Anyone here got the answer before I do the calculation as 0.74? Okay. Vidushana, very good. Yes. Very good. Right. So that is the second MCQ from chemical calculations they have given. Now we can go for the next one, MCQ number 12. That is not exactly the a calculation, but nomenclature. That is an application of oxidation numbers. So therefore, let's discuss that one also. Right, okay. Now, can you hear me now? Yes. Yeah. So the 12th one answer is actually the second option, but remember, students, cyanide is the correct term that we are using, but in the old syllabus, actually, they have considered cyano also, right? So since we don't have the correct answer that we are expecting, let's consider answer is 4. Right? For us, actually, don't have a correct answer for this one. Therefore, 4. MCQ number 12. Right. Let's move to the MCQ number 30. I think that's a titration, right? A 50 cubic centimeter sample of sample solution containing Fe2 plus is titrated with 0.02 moles per cubic decimeter potassium dichromate in acidic medium. The volume of dichromate required to react all the Fe2 plus is 25 cubic centimeter. If the titration is carried out using 0.02 moles per cubic decimeter potassium permanganate instead of 0.02 moles per cubic decimeter potassium dichromate, the volume of potassium permanganate required is. Now look at this one. MCQ number 13. So they have done the titration between Fe2 plus and dichromate. So in this solution, we have Fe2 plus, potassium dichromate, K2Cr2. So a 50 cubic centimeter sample of a solution containing Fe2 plus. This is titrated with 0.02 moles per cubic decimeter in acidic medium. The volume of dichromate consumed was 25. Right. So let me write down the balanced chemical reaction quickly. As an ionic reaction in acidic medium, Fe2 plus is reacting with dichromate Cr2O72 minus to produce Cr3 plus, Fe3 plus, and more. So to balance the reaction, first of all, put 2 here. So plus, sorry, plus 12 to plus 6. Decrement is 6. Plus 2 to plus 3. Increment is just 1 electron. Then this is multiplied by 6. 7 and 14 H pluses. Then we can find out the number of dichromate moles. 0.02 moles per cubic decimeter multiplied by 25 into 10 to the power minus 3 cubic meters. Cubic decimeters. So therefore answer is 25 multiplied by 0.02. 50. 5 into 10 to the power minus 4. Then what is the reaction stoichiometry between iron and dichromate? 6:1. So therefore, number of iron moles in the solution 6 times of this. That means 3 into 10 to the power minus 3. Right? So as they have given now the same Fe2 plus, right? If this titration is carried out using 0.02 potassium permanganate, how much of potassium permanganate required? So the same Fe2 plus moles. So therefore, same solution, same Fe2 plus is titrated against potassium permanganate, KMnO, in acidified medium, 0.02 moles per cubic decimeter, and they are expecting what is the volume. Then write the balanced reaction between permanganate and Fe2 plus in acidified medium, producing Fe3 plus. Permanganate is going to convert into Mn2 plus, and here plus water. So therefore, here we can say that manganese plus 7 2 plus 2 decrement is 5. Here plus 2 to plus 3, increment is 1. Then we can equalize them. I can multiply this one by 5. 8H buses. Okay. In the second situation, the concentration is 0.02, right? Please confirm that one. What is the permanganate concentration they have given? Is that 0.2 or 0.02? 0.02, right? Yes. Zainab, check it again. Then, students, we know that the same Fe2 plus moles. So Fe2 plus moles we calculated from the previous titration. That was 3 into 10 to the power minus 3. Then according to the reaction stoichiometry, the number of permanganate moles are 1/5 of this amount. That means 3 over 5 10 to the power minus 3 moles. Then you can find out the volume of permanganate. So this number of moles divided by the molar concentration. Molar concentration is 0.02 moles per cubic decimeter. So the answer will be 30. 30 into 10 to the power minus 3 cubic decimeter, which means 30 cubic centimeter. So this is the consumed volume of potassium permanganate. Right. So 30 cubic centimeter is given in the option number 5. Yes. Answer is number 5, right? MCQ number 13, answer is number 5. So raise your hand, those who obtain this answer before I do the calculation. Very good. Good, very good. Quickly do the calculation, and if you have any doubts, tell me. Yeah, partial pressure concept that is coming under gas laws. So therefore, let's keep that one to discuss that one under gas laws. Okay, Asma. Still, we are doing the gas laws. Ne? So after we completed the gas laws, so let's discuss that question. Now, MCQ number 15 is actually not gas laws. MCQ number 8 only gas laws. MCQ number 15 is vapor liquid equilibrium. That means unit number 12. Okay, so you can't do that question yet. If you know the theories, you can do. Otherwise, you can't get the idea. No? That is chemical equilibrium, not partial pressure. That's it. Right. Okay. Now let's move to the MCQ number 30. Yes. So that's also a calculation. A solid sample contains only calcium carbonate and magnesium carbonate. To completely react with calcium carbonate and magnesium carbonate present in the sample, 42 cubic centimeter of 0.088 moles per cubic decimeter HCl were required. The anhydrous chloride source from the reaction obtained by operation of the filtrate weighed 0.19 grams. The mass of calcium carbonate present in the solid sample. Right. So they have given there is a solid sample which is containing only calcium carbonate and magnesium carbonate. They have added HCl for this one. Then we can see that a double displacement reaction, calcium chloride, H2CO3 is produced, but that is unstable. So therefore, carbon dioxide and water. So same type of a reaction can be seen with magnesium carbonate as well. Right? Make sure to balance the reaction. So here we can put 2HCl, 2HCl, then the reaction is balanced. Okay. So they are asking here to find out the calcium carbonate present in the sample. Then let me consider this is X grams. Then what is the total mass? Have they given that? No, right? No, they haven't given. They haven't given. Right? Yeah. Then how we can go for the answer? So they have given the anhydrous chloride mass of that we obtain. Yeah, the anhydrous chloride salts from the reaction obtained by evaporation of the filtrate weighed, which is 0.19. Right? So I think we can start the calculation from there. What do you think? Because let me consider the calcium chloride mass is X grams. Right? Okay. Then I can say that magnesium chloride mass is 0.19 minus 6 grams in this way. Understood? Then I can obtain the molar mass of calcium chloride. Calcium is 40, chlorine is 35.5. Yes, 35.5 into 2 grams per mole. Then you're obtaining 40 plus 71, 111 grams per mole. Then magnesium chloride, molar mass is magnesium 24, chlorine 35.5 into 2 grams per mole. Then 71 plus 24, 95 grams per mole, molar mass. Then we can obtain calcium chloride number of moles are x grams divided by 111 grams per mole. Magnesium chloride number of moles grams per mole. Right? And students, they have given the total HCl concentration is given and the volume is also given 42. Then I can find out the total HCl moles. 0.088 moles per cubic decimeter multiplied by 42 into 10 to the power minus 3 cubic decimeter. Then what is the answer? So 42 into 88. Then the answer is 3.696 10 to the power minus 3. So these are the total HCl. So you can obtain that one from this reaction stoichiometry also. Calcium chloride and HCl reaction stoichiometry here 1:2. So therefore x over 111 into 2 number of moles. And this is 0.19 minus 6 divided by 95 moles into 2. Right? So we can obtain the HCl number of moles from the calcium chloride moles and magnesium chloride moles. Understood? In that way. Okay, now let's find out the X value. We are obtaining the calcium chloride mass. It's okay, fine. Later we can find out the calcium carbonate mass. So these are the total HCl. Then we can say that 2x divided by 111 plus 2 into 0.19 minus 6 divided by 95. This is equal to 3.696 10 to the power minus. In this way. Right? Now do the calculations. You have to do the calculations carefully. 95x plus 111 0.19 minus 6 equals to 1.848 multiplied by 111 multiplied by 95 10 to the power minus. So here calcium chloride molar mass is correct, right? 71 plus 40. Yeah. Then what is the X value? (111) multiplied by 19. 21.09 minus 111. Then here we have so the difference is 6. (16x). Right. So here we have to use logarithms. Huh? In order to do this calculation, we have to use 1848, 0. 11 1 95 0 9777. 2897 antelope. 2897 97. So 248. Ooh, 248. Then we have the answer 16x equal to 21.09 divided by 20.48. 0.61. So then x equals 0.61 divided by 60. So this is the mass of calcium chloride. Okay. 61 divided by 60. So here we have 3, 13. So 130, how much? How many 16s are there? 7, 8. Okay, so we can say that here 0.038. So this is the mass of calcium chloride. No? This is the mass of calcium chloride. But they are asking calcium carbonate mass. Ne? They are asking calcium carbonate mass here. Okay. Now, look at this one, students. Calcium chloride number of moles and calcium carbonate number of moles are same. 1:1. Then calcium chloride number of moles 0.038 grams divided by its molar mass 111 grams per mole. So these are the calcium carbonate moles. Then the mass of calcium carbonate can be obtained by its molar mass, 0.038 grams, 100 grams per mole. Calcium carbonate molar mass is 100 grams per mole. Then we have answer 3.8 divided by 111 grams. Okay. Let me take 380, 5798, 11, 1, 0453, 5, 4, 3, 5, 0. So 5345, 5345, 34 to 34 to 4. 10 to the power minus 2 grams. That means 0.034 grams. So that is the calcium carbonate mass. Do we have that kind of an answer? Oh my God, we don't have. So where did we do the mistake here? Anyone got the answer for this MCQ? Anyone here? So Vidushana, can you find out any mistakes here that we have done? So 0.088. 111 multiplied by 0.19. 1.848 multiplied by 111 multiplied by 95. 0.848. Yes, we did a mistake here. So this one should be 19.49. Yes. This is not 20, 19.49. Okay. Then I think we can go for the answer. So 21.09 divided by subtracted from 19.49. We are obtaining a correct answer. No? 21. So therefore 1.6. X equal 0.1. A nice answer. 0.1 grams. Right now, okay. So calculation errors. Yes, calculation errors. Huh? Then 0.1 grams divided by 111 grams per mole. And the mass of calcium carbonate should be then 0.1 grams divided by 111 grams per mole multiplied by 100 grams per mole. So cancel off. So therefore answer will be 10 divided by 111 grams. So 10 divided by 111, 0.009. Yes, 0.009. Yeah, we are obtaining the correct answer. That is the answer. Question number 30. Answer is number 3. Students, see, look at the calculations they have given. Okay. These are the past exam calculations. Okay. You are not given calculating the exam. Huh? Keep that in your mind. MCQ number 30. So that's a good MCQ, right? Quickly complete this one. So I got the third answer. I wrote both the equations as one equation and got it. Pranali, send me that work, okay? Through WhatsApp. I'll check that. Right, okay, quickly raise your hand. Those who understood the discussion, the calculation in MCQ number 30. Quickly raise your hand. Do you have any doubts here? Anything? So if you are given this kind of a calculation in the exam, remember students, it's not easy. So better you practice these kind of calculations more. These are the chemical calculations. Chemistry part is okay, but dealing with the mathematical part, right? Simplifications. So that is the issue. Sometimes we can't get the correct answer. Right, okay. Now let's move to the essay paper. So these are the MCQs that they have given from chemical calculations. Now let's move to the essay paper. In the essay paper, we have two questions. Question number 8, part C, and question number 10, part B. Essay paper, question number 8, C part. A sample given for analysis was found to contain sodium hydroxide and sodium carbonate and an inert water soluble substance. The following procedure was used to determine the percentage of sodium carbonate in the sample. Right. So therefore, the intention of doing this experiment is to find out the sodium carbonate percentage in the sample. Note, the inert substance does not precipitate in the reactions in the procedures given below. So let's go over the procedure. A weight of 42.4 grams of the sample was transferred quantitatively to a 500 cubic centimeter volumetric flask and made up to the mark with distilled water. The flask was shaken thoroughly and solution X is prepared. So there is a substance. So there is a chemical mixture. 42.4 grams, which is containing sodium carbonate, sodium hydroxide, and some inert substances. And they have dissolved this one in a volumetric flask, 400 cubic centimeter volumetric flask, and prepared a solution. Right. Now, in the first process, they have given that a 25 cubic centimeter portion of solution X was titrated with distilled water solution, distilled HCl, with a dilute HCl solution using methyl orange as the indicator, using the until the color change from orange to red. The burette reading at the end point was 32 cubic centimeter. Right. Now look at the process they have given. So they have taken a sample of 25 cubic centimeter, and this is titrated with diluted HCl using methyl orange as the indicator. Diluted HCl is added and methyl orange is the indicator. Okay. And the end point, that means the consumed volume of HCl is 32 cubic centimeter. This is what they have done in the process number 1. In the second process, they have given like this: a 25 cubic centimeter portion of solution X, another sample is taken, was warmed to 70 degrees Celsius, and 1% barium chloride solution was added in slight excess, the barium carbonate precipitate foam was filtered. So they have added barium chloride to this solution. Then barium carbonate precipitate is formed because sodium carbonate is there. Remember, students, in inorganic chemistry, we are learning that barium carbonate is actually precipitate. Barium carbonate, yes. Barium carbonate is a precipitate. White color precipitate. So therefore, we can consider that all the sodium carbonate converted into barium carbonate by addition of barium chloride. They have given that they have added excess amount of barium chloride. So therefore, we can say that exactly barium carbonate is produced. All the sodium carbonates converted into barium carbonate. And the filtrate was titrated with diluted HCl using phenolphthalein as the indicator until the color changed from pink to colorless. The burette reading at the endpoint was 24. Understand the process. They have taken another 25 cubic centimeter sample, right? So they have added barium chloride for this one. Then we know that precipitate is produced, barium carbonate precipitate. And they have filtered that precipitate, and the filtrate is taken in this way. So this is the filtrate. Right. So the filtrate is again titrated with HCl, diluted HCl, using the phenolphthalein as the indicator. So this time the volume consumed was 24 cubic centimeter. Is the processing number 2. Then let's go for the third process, number 3. To a 25 cubic centimeter volume of diluted HCl solution. Now we have used diluted HCl in both the two processes that they have mentioned. So, but they haven't mentioned the concentration, right? I think the third process is explaining how to find out the concentration of that diluted HCl. 25 cubic centimeter of volume of the diluted HCl solution, 5% of potassium iodide, 5% of potassium iodide solutions were added in excess. The liberated iodine was titrated with 0.5 moles per cubic decimeter sodium thiosulfate solution using starch as the indicator. The burette reading at the endpoint was 12.5 cubic centimeter. Question number 1. Determine the concentration of HCl solution. From number 2. Calculate the percentage of sodium carbonate in the sample. From number 3. State any assumptions made in calculating the above. Right. So in the third process, actually, they have taken 25 cubic centimeter of HCl. And they have added here potassium iodate along with potassium iodide. And iodine is liberated. That iodine thiosulfate titration is also done. So sodium thiosulfate. Right, okay, now let's go for the calculation, right? So they're asking from number 1, determine the concentration of HCl. So students, we know that here potassium iodide, they are reacting together in the presence of H pluses to produce iodine. I minus is also converted into iodine. IO3 minus is also converted into iodine. Right? So in this reaction, we know that here 2 iodines are there, minus 2 to 0. Increment is 2 electrons. So here plus 10 to 0. Decrement is 10 electrons. So we can multiply this one by 5. So 12 H pluses are there. So therefore the balanced reaction is 6 H pluses, IO3 minus plus 5I minus producing 3I2 plus 3 water molecule. And then they have given this iodine is titrated with sodium thiosulfate. So that reaction also can be written as Na2S2O3 producing sodium tetrathionate Na2S4O6 plus sodium iodide NaI. Then put 2 here and 2 here. Then the reaction is balanced. Right? So consumed volume of sodium thiosulfate is 12.5, concentration is 0.5. Then you can find out thiosulfate number of moles. 12.5 10 to the power minus 3 cubic. So therefore answer is 12.5 multiplied by 5, 625. So therefore 6.25 10 to the power minus 3. So the reaction stoichiometry between iodine and sodium thiosulfate is 1:2. So therefore the number of iodine moles are half of this one. Then iodine and H pluses reaction stoichiometry is equal to 3:6. That means 1:2. Then H pluses moles, number of H plus moles equal to 2 times of that means 6.25 10 to the power minus 3 moles. Now you can find out the molar concentration. So they have used here 25 cubic centimeter volume. Then molar concentration of HCl is equal to 6.25 10 to the power minus 3 moles divided by 25 into 10 to the power minus 3 cubic decimeter. So therefore answer is 0.2 0.25. So this is the molar concentration of HCl aqueous solution. So let's see how they have allocated the marks. For this balanced reaction, they have given 4 marks. For this iodine thiosulfate reaction, they have given only 2 marks. For the calculation of thiosulfate moles, they have given 2 marks. For the calculation of iodine moles, they have given 2 marks. For H plus moles, they have given 2 marks. And for this substitution, they have given 2 marks. For the final answer, they have given. Yeah. In that way, they have given marks. They have allocated the marks in this. So first of all, using the third process, we found the H plus concentration in the solution. That's what we have done. Quickly come up to here. Uh, yeah, we can write down that one, but Vidishana, they have allocated the marks for ID number of false. Eh? Sometimes in the exam, you will get the full marks for that. It's okay, but better you mention separately. Yeah? Understood? Quickly complete this one. I'm going to erase the whiteboard part, so therefore quickly do it. Right, okay. Now, since they're asking the sodium carbonate percentage in the sample, now let's go for the calculation for finding sodium carbonate percentage. Now we know that HCl molar concentration is 0.25. Right. Now look at this one. Students, in the process number 1, they have given in the presence of methyl orange indicator, diluted HCl is added, and in the solution we know that sodium carbonate and sodium hydroxide both were there. So both are actually having the basic nature. Neither. So we discussed about the sodium carbonate HCl titration in the theory class. So in the presence of methyl orange, that is going for the completion. So let's write down the reaction first of all for the process number 1. Sodium carbonate is reacting with HCl, produce sodium chloride, carbon dioxide and HCl. Sodium hydroxide is reacting with HCl, produce sodium chloride plus, so here 2 here, okay, in this way. So in that process, how much of HCl consume? 32, right? Then I can find out here number of HCl moles reacted with both sodium carbonate and sodium hydroxide. Both sodium carbonate and sodium hydroxide. What is that amount? Molar concentration 0.25 moles per cubic decimeter multiplied by volume is 32 into 10 to the power minus 2. Then 25 into 32. .8 8 into 10 to the power minus 2. Okay. Students, now go for the second process. In the second process, they told us that they have added barium chloride. So when we add barium chloride, what will happen? When we add barium chloride, sodium carbonate is reacting with that one. Barium carbonate is precipitated. They have clearly mentioned that. Barium carbonate precipitated. That means all the sodium carbonate now converted into barium carbonate. All the carbonates are converted into barium carbonate. That means after addition of barium chloride, now in the solution, there are no sodium carbonate. Then what is the remaining thing? What are the remaining base we have? Sodium hydroxide. So after filtrate that precipitate, they have taken the filtrate, added HCl. Now this HCl is reacting with whom? Only sodium hydroxide. Only sodium hydroxide. Then I can say that number of HCl moles reacted in the second process with only sodium hydroxide, that amount is equal to 0.25 moles per cubic decimeter multiplied by 24 10 to the power minus. So 25 into 24. Six into 10 to the power minus 2. We know that in the both process, the same volume used, right? So therefore, no issue. Now, can you tell me how much of HCl consumed to react with sodium carbonate only, right? Now, in the first process, we know that HCl is reacting with both sodium carbonate and sodium hydroxide. We don't know how much of HCl reacted with sodium carbonate, how much of HCl reacted with sodium hydroxide. But in the second process, since they have removed the sodium carbonate from the solution as barium carbonate by precipitating, now in the solution, remaining thing is only sodium hydroxide. That sodium hydroxide reacted with HCl, then that HCl amount was 6 into 10 to the minus 3. Then students, you can see that the difference between these two is giving the number of HCl moles reacted with sodium carbonate. Can you understand what I'm saying? So we can say that the difference between these two, number of HCl reacted with sodium carbonate only, can be taken as the difference between these two. What is the value? 2 into 10 to the power minus 3. Okay. So raise your hand who understood the process up to now here. Everything. Raise your hand. Now we know that sodium carbonate and HCl reaction stoichiometry. What is it? Sodium and sodium carbonate HCl reaction stoichiometry 1:2. Then sodium carbonate number of moles in 25 cubic centimeter is half of that, 1 into 10 to the power minus 3 moles. So what they're asking really in the question, calculate the percentage of sodium carbonate in the sample. Now, these are the sodium carbonate number of moles in 25 cubic centimeter, right? Actually, initially the prepared solution was 500 cubic centimeter. Initially prepared solution was 500 cubic centimeter. Then I can find out sodium carbonate number of moles in 500 cubic centimeter. In 25, we have this much. Then in 500, we have how much? 2 into 10 to the power minus. Okay. Then we can say that the mass of sodium carbonate, before that molar mass of sodium carbonate, 106 grams per mole, right? Then mass of sodium carbonate, number of moles 2 into 10 to the power minus 2 moles multiplied by 106 grams per mole. So therefore, 212, right? 2.12. And then find out the mass percentage. So what is the total mass? 42.4. 2.12 grams multiplied by 100%. Grams will cancel off. Here we can say that is that 5%? Yes, answer is 5%. So let's see how they have allocated the marks for these things. For writing this reaction, they have given 1 mark. 1 mark for this one. For finding the number of moles of HCl reacted with both sodium hydroxide and sodium carbonate, 3 marks. For finding this sodium hydroxide, number of HCl consumed to react with only sodium hydroxide, this one. And for taking these two difference, 3 marks. Finding this number of moles, 3 marks. Sodium carbonate moles, 3 marks. In 500 cubic centimeter, 3 marks. For finding this mass, 3 marks. For this expression, 3 marks. For the final answer, 3 marks. This is how they have allocated the marks in the marking scheme. So this is the calculation in that essay question. Raise your hand those who understood the complete calculation in that essay question. So that's a good essay question. Yeah. If you have any doubts, put your doubts in the chat box. They're asking another question, Rome number 3. State any assumptions made in calculating the above. Can you tell me what is the assumption that you made in the calculation? Can anyone tell me what is the assumption that we made? I told you that. Can anyone try? Yes, all the sodium carbonate converted into barium carbonate, right? All the sodium carbonate converted into barium carbonate without remaining any sodium carbonate in the solution. Otherwise, this calculation is wrong. Sodium carbonate is remaining without precipitating in the second process. Then when we add HCl, that HCl can be reacted with that remaining sodium carbonate as well. So therefore, we have to assume that all the sodium carbonate precipitated as barium carbonate. Okay. So let me write down that one here. All the carbonate in the solution, all the carbonate in the solution is precipitated as barium carbonate on the addition of excess barium chloride. Okay. So for this calculation, for this answer, they have given 5 marks. For that calculation in the exam, they have given 50 marks. Okay. 50 marks for this calculation. So this is a part of essay question, right? So it's not easy to collect this 50 marks. Don't think that this is very easy. See how much of things that we have done. You can count out of 50 how much you have obtained. Anyone here 50 out of 50 for this essay question? Didn't you check? Forty-four. I didn't write the names. Every step is very important. Vidishana, keep that in your mind. Right, okay. Are we done? Shall we move to the last calculation? Question number 10 or B? So let's move to the essay question number 10, part B. So let's see what kind of a question they have given here. A solution T has been prepared by dissolving 0.3 grams of ferrous oxalate in dilute sulfuric. The solution was heated to 65 degrees Celsius. Calculate the volume of 25 moles per cubic decimeter. Potassium permanganate solution reacted completely with. So that's very easy. So this is a kind of MCQ question. Sulfuric is reacting with ferrous oxalate FeC2O4 and potassium permanganate, producing ferrous sulfate converted into ferric sulfate, oxidation, right? Fe twice, SO4 thrice, carbon dioxide, manganese sulfate plus water. Now do the balancing part. Manganese plus 7 here, plus 2. Plus 7 to plus 2, you can see that the decrement is 5 electrons. And here too, plus 4 to plus 6. Plus 4 to plus 6, you can see that the increment is. Wait, you know that there are 4 carbon atoms here, right? Now, after balancing the iron atoms. So therefore, we can't ignore the carbon. Because carbon is a carbon here, carbon's oxidation number here is plus 3. There are 4, so therefore plus 12. So here we have to put 4, then plus 6. And here plus 6. So what is the total increment? Plus 16 to plus 26. 6 electrons. This is multiplied by 5. And this is multiplied by 6. We know that there is another byproduct, potassium sulfate, K2SO4. So therefore 3 here. How many sulfur atoms are there? 3, 9, 15. So 24 sulfur atoms are there. How many oxygens are there here? Then the reaction is balanced. Okay. We have discussed this reaction in the theory class. You check the note, you will see. Right. So now they're asking what is the volume of potassium permanganate required to completely react with this ferrous oxalate? So the ferrous oxalate mass is given 0.3. What is the molar mass of ferrous oxalate? Iron is 56, carbon is 12 into 2, oxygen is 16 into 4 grams per mole. (144 grams per mole). Then number of moles of ferrous oxalate, 0.3 divided by 144 grams per mole. So this is divisible by 3, right? Therefore 0.1 divided by 48. So what is the reaction stoichiometry between ferrous oxalate and potassium permanganate? 10 is to 6, which means 5 is to 3. Then I can find out the potassium permanganate number of moles. For 5, we have 3. So this 0.1 over 48, how much we have? Okay. Then they're asking here, what is the required volume? Volume equals to number of moles, 0.3 divided by 45, 48 into 5. Molar concentration they have given 0.025 moles per cubic decimeter. Right. Now do the calculation. 16. Sixteen into 5 is 80. 80 multiplied by 25. 1,000. Point 1 divided by 2 cubic decimeter. That means 0.05. In cubic centimeters, 50 cubic centimeters is the answer. Raise your hand those who got the answer as 50 cubic centimeters. Very good, very good. Okay, I'll give the marks. How they have given marks for this one? Uh, if you have balanced this one correctly, they have given. Surely they have given 2. 14 marks for this one. For finding number of moles, 3 marks. For the oxalate, for this answer, they have given 3 marks. Stoichiometry ratio, assign 3 marks there. Three marks for this one. Five marks for this one. So the mark scheme, the way they have given marks a little bit different, but anyhow, put the marks in this way. So these are the key steps actually. So for these key steps, they will give marks. Remember in the exam, if they have given you to balance the reactions using half reaction method, then you have to show the half reactions. But in this question, they haven't mentioned that one. So therefore, no issue. Right. So these are the chemical calculation questions in the 2013 A-level paper. Right. So in the next week, we can discuss 2014 A-level paper. And let's see what are the chemical calculation questions that they have given in 2004. Right. So what are the doubts you have? Is everything okay? Can you understand this calculation? Any doubts? Raise your hand those who understood this calculation.